Okay, in this section of our factoring module, what we're going to do is that we're going to take a look at factoring out a common term of a polynomial. And that's a real important one to go ahead and get down. There's two different ways that people do it, and I'm going to show you both. And so hopefully you can fall in love with one way, take it to the dance, marry it, etc., and just be able to use it for the remainder of your mathematical career. So let's go ahead and take a look at this guy. So the first thing that we want to do is that this the first way that I'm going to show is that we're going to go ahead and we're going to factor each one of these guys right here, the parts of the polynomial. So that basically means is that this 3 is a 3 right here, and x squared is x times x plus, and now I'm going to go ahead and factor out the 12. Sometimes it's easier to go ahead and do a factoring tree like this. Okay, so 12 breaks down into 1, 3, and then 4 breaks down into 2 times 2. So we end up with this guy right here, 2 times 2 times 3 times x. And really these are all being multiplied by one another. And then what we do is that we just look at this and say, okay, well, what do each one of these right here, okay, have in common? That is that this one has an x and this one has an x. So I can take an x out of each one of those. And I also have a 3 in common with each one of those, and I can take that out. And since I don't have anything left in common, because over here in this term is this an x that is left, a plus sign, and then 2 times 2 over here, which we know is going to be 4. That's what's left. And so I have successfully then, oops, that's the wrong marker there, successfully went ahead and factored out a common term, 3x, from the original polynomial right here. Okay, so after we get that looking all good, then this is going to go ahead and be our factored solution. Our way to check this, okay, is that if I wanted to check my solution and make sure that I factored that correctly, is that I can start off with what I factored out right here, so my solution basically, and then I can check it by redistributing this back in and see if that gives me the same thing that I started with up here. So let's try that. 3x times x is 3x squared, and 3x times 4 is going to give me 12x. So since these are the same, I know that this is going to go ahead and be correct. And so we like when that goes ahead and matches. Okay. Now, I'm going to go ahead and show you another way to do it. And I'm just going to scoot this on over a little bit. And we start off with the same thing that we started with, because we're looking at a different way. And so what I like to do is I think about it like this then. Obviously, we have the exact same problem. I just moved it over here so I can write some. But what I like to do is that I like to go ahead and take a look at all the coefficients here. And I say to myself, what is the largest number that can divide into the two coefficients? This one's a 3 and this is a 12. So the largest number that can divide into those is going to be a 3. So what I do then is that I put a 3 under each one of those, and I'm going to go ahead and be able to bring that 3 out. 3 divided by 3 is 1. 3 divided into 12 is 4. Okay? So far, so good. Now, I go ahead and take a look at this business of the x's. And so the x's, I know that there's 2 x's right here, and there's 1 x right here. So therefore, I can go ahead and at most divide an x into each one of those, and then I'll bring the x out here. Oops, that's a 3. Oh, that was a bad one. And what's going to go ahead and happen here is that as we learn how to divide um, rational expressions earlier on in the year, is that this part right here is going to go ahead and cancel out, and I'm going to be left with 1x, and these x's just are going to cancel out, and I'm left with no x's. And so that will give me x, okay, from this part. So that would be like the one canceling the one out, and leave us just with x, and x divided by x is just going to go ahead and cancel out. So that would just give me then the 4, which is right here. So what's left then, to make sure that we follow along, was this guy, okay? And that is what goes inside the parentheses. What you divide by was outside the parentheses, 3 in the x, okay? And you can see that if we checked it, it's the exact same thing, it would check out. And so that is going to go ahead and be, oops, I keep doing that, is going to go ahead and be how to go ahead and factor out a common term of a polynomial. So I'm going to take a look at a bunch of other examples because they change a little bit from example to example, but that's a good start. So see you at the next problem. Okay, let's slide over to this next example over here, and we're going to do the way that we did the last one, starting off where we're going to factor everything all the way. So factoring this part first, 4 can be broken down in the 2 times 2. So we'd go 2 times 2, and then we have 2 x's, x times x, plus, now 16 can be broken down into a bunch of 2's. 2 times 2 is 4, times another 2, 8, times another 2, 16, and then an x, and then at the very last part here, we got that 4, which is going to break down in the 2 times 2. So now we're going to go ahead and gather, okay, which numbers or variables does each term in the polynomial have to give. So we're going to go, all right, there's a 2, I'm going to take that out, and then there's another 2 that's common with both, and I'm going to take that out. And what's left is x times x, which is x squared, plus, if I look over to the middle term, 2 times 2 times x, which is 4x, plus, now, here is something that is really, really important. When we look right here, if we take both terms out, okay, or if we take all the terms out, we need to go ahead and put a 1 as a placeholder here. And I'm going to show you why in a minute, okay? So, and that will hopefully make sense in a minute. So again, when you take both terms out, you got to go ahead and put a placeholder here. You can't just put a 0. So when I clean these up, bringing everything down, I got 2 times 2, whoops, wrong marker, which is going to go ahead and give me 4x squared plus 4x plus 1. So now, this is our supposed factoring solution. However, since we're either new or reviewing, let's go ahead and do a check our answer. And so to check our answer, I'm going to rewrite the proposed answer here, and then I'm going to redistribute that. So 4 times x squared is 4x squared plus 4 times 4, which is 16, and then the x, plus, and this is why that 1 is important, because when I go ahead and I distribute it back into the polynomial, I get 1 times 4, and so that is, oops, I don't need a parenthesis there, is going to go ahead and give me the original, okay, polynomial. If I had a 0 here, then this would turn into a 0, and then this, it wouldn't match, okay? So that's why the placeholder is going to go ahead and be important. Now, let's go ahead and also do it the way that, the second way that I did the first one with, and that one is basically looking at, okay, well, what can I divide into each one of these evenly? All right, and so when I say these, the terms of the polynomial. So let me rewrite this thing. And I look and I'm just like, okay, well, I can see that each one of these doesn't have an x to give. This has a x squared, this has an x, and this one doesn't have any x's. And so therefore, I'm not going to be able to pull an x out. But if I look at these coefficients right here, the 4, the 16, the 4, I can ask myself, well, what number divides, the biggest number that can divide into a 4, a 16, and a 4 evenly? And so I'm going to go ahead and divide each one of those by 4, because that's what it is. 4 can go into each one of those evenly. So I bring that out, and now I look for cancel, and I just bring down the x squared, plus 4 in the 16, which is going to be 4x, plus 4 divided by 4, which is 1. And then we have the exact same solutions, just using a little bit of a different method, okay? Again, folks that have a tougher time in algebra probably want to use this method. Folks that can see things a little bit more thoroughly probably want to stick to this guy right here. Okay, so on to the next. Okay, here in this next example, we got something that is 2x squared plus x. So in this case, we're going to do it both ways again. And then I'm probably just going to stick to one way after this. So we break everything down. Okay, and in this we can see that we have this business of each one of those terms has an x I can take out. Okay, so I'm going to do that. Bring the x out, not with the highlighter. Always forget the switch. Oops. So we got x, this x that I brought out. And what's left is 2x, and I took everything out of this guy right here, and so therefore, I have to put a plus 1. Okay, checking my work. Okay, because this is my proposed solution, and if I multiply it back in, then, and I have what I started off with, then I know I'm all good. So, put that back in like that. So 2x times x is going to give me 2x to the second plus 1 times x, which is x. And we're in good shape because this matches this. Okay. So it can work the other way too, is that we could say that each one of those has an x to give, right? This one has 2, this one has 1. And so what we do is that we can divide then x comes out in front, and I end up with 2x plus 1, which is the same thing that I got over here. Okay, so we're going to go ahead and go on over to some examples that require a factoring out a negative in this case, and it is something that will come in handy a little bit later. Okay, so what we're going to do is that we're going to take a look at just kind of like a general rule here, is that if your polynomial starts with a negative, we know that we can go ahead and leave it like this, and this would be fine. Or we could go ahead and factor it out, the negative sign, to each one of those like a -1. So for example, if I have that negative there and I want to factor it out, I can say to myself, okay, I can divide each one of these by a -1. A -1 comes out in front like a negative sign, and that's going to flip both of these signs right here. So a -2 divided by a -1 is going to give me 2. And if I look over here, +7 divided by a -1, that's going to give me a -7. Okay? And oftentimes, we just leave it like this. Okay? That is that if it's a 1, we leave it like that. And why does it work? Because if we go ahead and distribute the negative sign into each one of those, that's going to flip the signs back, and we get a -2x plus 7, which is what we started off with, which means is that that's factored correctly. So this would be the preferred way to write that. Now, the last bit with the negative part is this guy right here. So we have a negative out in front, and we want to rewrite that so it doesn't have the negative out in front. We want to factor that out. But we notice also that each one of these coefficients right here are divisible by 5. So what we're going to do is that we're going to divide each one of these terms by a negative 5, because that's going to take the 5 out, and it's going to take the negative sign out all in one step. So I take a negative 5 out, and I'm going to cancel this. Negative 5 divided by negative 5, and that is just going to cancel. Now I'm left with x squared. Negative 15 divided by negative 5 is just going to give me a positive 3. And then positive 20 divided by negative 5 is going to give me negative 4. Okay. And this is going to be the preferred way that we write that. Okay. Once more, we can check it by putting each one of these back in and saying a negative 5x squared is going to give me a negative 5x squared. Okay. Negative 5 times positive 3x is a negative 15x. And a negative 5 times a negative 4 is going to give me a positive 20. So, again, it matches what I started off with. So that's how you factor out a common term of a polynomial. And these are examples that are going to help us be better factorers later on down the line, because we're going to need this factoring out a common term polynomial for a bunch of different stuff that we're going to be doing later on this year. So that's how you do that, and I will see you in the next video.